Thanks, Ed. As Ed mentioned, my name is Andrew Wooster. I'm the product manager for the Bullhorn products, and today I'm excited to give a glimpse into the new RM5 satellite unit. So at the end of last year, we introduced the RM5 cellular system, and now we're bringing to the table the satellite communication. So today I'd like to talk about, well, we have the cellular version. What are some of the benefits that we have for the satellite system? And the nice thing is that many of these benefits are going to span both communication types, but I'll dive right in. So the key difference between the cellular version of RM5 and the satellite version of RM5 is the communication. So in the new version of RM5 with satellite communication, we're using the Iridium network. This is a low Earth orbit network consisting of 66 satellites. And what's great about how this network is architected is that it creates a mesh over the entire surface of the Earth for communication. One of Iridium's kind of biggest industries that they serve is with satellite phones, and so you can talk anywhere on the face of the Earth with a satellite phone on Iridium's network. And likewise, you could install a Bullhorn RM5 satellite unit on any point of the Earth, and you're going to be able to get the connection that you're looking for. Along with moving to this low Earth orbit style of satellite network comes a benefit on the installation side with your antenna. So with our legacy RMUs, what we have is a geostationary satellite constellation. And what this means is that up around in outer space around Earth, there are satellites that are sitting in a distinct spot above the surface of the Earth. And in a lot of cases, what this means is that the satellite is right over the equator. So the challenge that this poses for installation of RMUs is as you move further north or further south towards the poles, you have to direct that antenna towards the equator to get a line of sight view of that satellite. And in some cases, we can't even achieve a line of sight for those satellites. And so many of you and some of our customers have found that in really northern locations, satellite with our legacy RMUs just isn't possible because you can't get that line of sight. And so what ends up happening is, you have to rotate the antenna to point it where you need it. And you have to kind of play with it until you get the connection that you need. With our next generation RM5, however, in this low Earth orbit satellite constellation, you simply just need to point the antenna to an open view of the sky, and you're going to have satellites floating by all day long, every day for the entire year. And it's much easier to establish that connection with the satellites using the Iridium network.
So Andrew, looks like Brad agrees with you in the comments.
Yeah.
A Canadian has said, yes, you're right. So that's good.
A second benefit is on the installation and configuration side. Now, one thing that I do want to point out is that between the RM5 system cellular version and satellite version, these systems are identical up into this module right here. So this is the dome. This is where the antenna is housed. And so all of the components, the IO module, the power supply, the relay, the terminal blocks, these are all common to the RM5 cell and RM5 sat versions. And so if you have chosen to go with a cellular version of our RM5 and you find out, hey, the location that I'm installing just doesn't have a cellular connection, we are providing an easy path for you to move over and switch to the satellite version of the product. And all that would require is just swapping out this dome piece. No other installation changes would be required. And so our documentation from a hardware installation standpoint, we provide wiring diagrams, the wires coming out of the IO module to connect to your RMU and all measurement locations are color coded to match our documentation. And so we tried to simplify this as much as possible for your installation process. Once you have all your hardware installed, then it needs to be configured. Now, when we introduced the cellular version of the RM5, we also introduced support into Bullhorn Web for configuring. And in cellular, you can do the configurations in Bullhorn Web because the data cost isn't what it is with satellite. And so you can make updates. The communication is happening more frequent than it would with satellite. But with satellite, it's to your benefit to make all those configurations, all the initial setup, in the field while you're there. And so along with the introduction of our RM5 SAP hardware, we're also introducing a new version to Bullhorn Tools, which is our mobile app for doing configuration, querying device information, doing firmware update of your devices in the field. This is a free download, no extra cost on top of the cost for your hardware and your communication plan. And really the key things that it provides is on-site configuration and validation of those measurements. You can actually in the app query channels and see the voltage measurements that you're reading. And although this is being introduced with RM5 satellite, it is also compatible with the RM5 cellular version of the product as well. So we now have the Bullhorn Tools app, and this is Bullhorn Tools 3.0 when this comes out at the end of the month. It will allow you to do field configuration and information querying for both the RM5 satellite and RM5 cellular versions of the product. And then, of course, Bullhorn Web has also been updated to support the satellite version of the product as well, to provide you a path to view your data, to do configurations, generate reports, all the things that you've come to know and use in your workflows using Bullhorn Web. Sorry, did I hear a comment?
Oh, just Bullhorn Tools. It communicates through Bluetooth. So
correct. So there's a Bluetooth connection that can be enabled on the RM5 hardware with a swipe of a magnet on the I/O module, and yeah, it is a Bluetooth communication. And when it is released, it will be available on the Google Play Store as well as the Apple App Store for your phones, for tablets, like our Mesa 3 rugged tablet. You can download the app onto that via the Google Play Store. A third benefit is on reliability, and we've talked a lot about this with the introduction of our cellular version of the product. But I wanted to bring it up again because it's a very important piece of our new architecture. So, what's the problem? Well, this is a pretty common scenario for the environments that the RMUs are being installed in. Lightning. It's one of the most invasive, one of the most destructive things to electronics anywhere in the field, especially RMUs that are attached to pipelines, to large metallic structures that love to carry all of that energy from lightning. And so what is the solution that we've done with the RM5 system to help mitigate some of that risk from lightning hitting the pipelines, hitting other structures, and flowing through ultimately to the RMU? The solutions that we've implemented, and I'm missing one here. There we go. So the first three bullets there are really, we can't prevent the energy from lightning from ultimately coming into the electronics if that's what it's going to do. What we can do is limit the ability of that energy to spread through the device once it's entered. And so the first three bullets there, really what we've done with those is, once it enters the device, the thing that really can destroy electronics is when it then arcs to other parts of the system, of other parts of the electronics. And when it starts arcing, that's where it starts to hit components that are more sensitive, microcontrollers and other less power resistant components. And so we have fully potted electronic assemblies. This is where we literally fill the mechanical enclosure with a goo that hardens. And so there's no path for arcing to travel through because it's blocked by this hardened material, this potting material. For the I/O module, we have flying leads, so there's no terminal block or no screw terminals that are external to the I/O module that would cause arcing to occur from channel to channel on the outside. The digital channels do have a screw terminal block, but the analog channels that are most likely going to be receiving the energy from lightning, those are all flying leads. And internally, on the device, those leads go through and they solder directly to the board, and then they are then potted around to prevent arcing from channel to channel. And then we've also, if you notice the small item on the far right there, that's the terminal block. What we've done is we've taken the majority of the connections for those analog channels outside of the system, the RMU system, so that any arcing that may occur, let's say the surge event is just way beyond what the device itself could handle, even the potting. Well, we've created a kind of the weakest link in the system is this terminal block. And so if there's any arcing, that's where it's most likely to occur. And if there's any damage that requires you to go back out into the field, the advantage here is that you have to replace a $10 piece of hardware rather than electronic components that can be much more costly to replace. In addition to all of those things, the power supply and all the power that, when you connect your RM5 to receive external power, it's designed to receive that power from the secondary taps of the rectifier. So this gives you yet another barrier from the diode stack, from any other surge prevention components that may be installed on the rectifier. It gives you yet another layer of protection from surge by powering from the secondary taps of the rectifier. The fourth benefit, the overall AI ecosystem. And what do I mean by that? Well, we have products that span all the workflow of CP, CP mitigation, CB monitoring. And so on the Bullhorn side, you collect that data in the field and it's brought into Bullhorn Web. On the field data collection side, when your technicians are conducting surveys down the pipeline, we have our PCS field integration products where they're collecting that data and they can bring it up through wireless sync into Survey Manager for review. And then ultimately, all of this data from Bullhorns, from the field integration side can then be stored within PCS. And so we've provided an overall ecosystem of products that work together. They work together and we're continually evolving the ease of which those work together, as Ed mentioned earlier with our Bullhorn Web and PCS integration effort. We recognize that there's still improvements to be made on that integration, but today they can be integrated and they are integrated. And so that's what we mean by the overall AI ecosystem, is we've provided a total solution for you for all of your CP survey and monitoring needs. And the fifth benefit to this product, and a lot of times we look at the product itself, we say, oh, that's cool hardware, that's cool software, that's it. Well, it doesn't stop there. You need to learn how to use it. You need a helping hand sometimes to resolve issues. And so we have a whole secondary product, if you will, that involves video training. We're constantly updating our videos on our website. We also have a YouTube channel that provides information about product usage, installation, best practices, and so forth. And so this video training is always in process, always being updated to give you the freshest information that you can use for the installation and management of your devices. And this spans all of our products, not just the Bullhorn. It includes our field data collection tools. It includes our software. And so that's available to you to use. On the customer service side, if you need information about your account, about your billing, about your service plans, payments, invoices, POs, we have a great team serving all of those needs because it's a very important need that you will have when you're purchasing and maintaining these devices. On the technical support side, we have email support, we have phone support, we have a team of technical support folks that know the industry in and out. We have CP certified technicians on our team working directly with you. They know what they're talking about and can help you, especially at the points of install or the point, if you're running into issues retrieving your data, we're there to help you. And I put a boot up there because in a lot of cases in the past, and depending on the issue, we literally are boots on the ground with you to help you resolve issues if it comes to that. And so technical support is something that we take a lot of pride in, and we put a lot of importance on, because we realize that it's not just about buying our products, it's about being able to effectively use them. And then on the documentation side, this kind of pairs with our technical support, but really gives you the ability to self-serve on any support needs that you might have. We've got quick reference guides, we have our user guides, links to all the video training, and this is for existing, present generation products as well as legacy products. It's all there ready for you to use. And with that, those are the 5 benefits that I have to talk about. They are certainly not the only benefits to talk about with the RM5 system or our Bullhorn products, but I hope that gives you a little more insight into what we've got with RM5 satellite. And I'll leave the floor open for some questions and answers. I think we have a little bit of time.
When will I receive one if I buy it?
We're right now tracking to release formally the RM5 satellite at the end of the month, and we have our procurement team queuing up inventory of all the components and preparing to ship today. Or by the
Sounds like a verbal PO, Ed, so we'll get those out right away.
Well, I think we have some orders. I think, when we said early summer, I think end of the last week of this month, we'll start trickling out some of the first few units, I think. Great.
Did we get any questions in the chat?
Not very many, but I think we could to clarify about utilizing Bluetooth on Bullhorn tools.
Sure. So there was a question. What was the question or comment?
Just kind of like how Bullhorn tools connects to your RMU.
Okay, sure. So I can do some modeling here. So on the IO module, there is on the side in the plastic a small triangle, and then there's some labeling on the top of the label to indicate it. At this point on the IO module, you can take a magnet and swipe it, and what it does is it will activate the Bluetooth communication for the whole system. At that point, when you open up, and we'll have, let me just take an aside. We are working on and we'll have video training supplied for this on that video training site that I referenced on one of my previous slides that'll show you this process. It's also going to be in our documentation on how to do this, but you swipe here with a magnet, it activates Bluetooth, and at that point, your device, when you open the app, the Bullhorn Tools app, your device will be discoverable on that app. You click on it, and you're into the interface to communicate with it. And that's actually the same, that magnetic swipe and viewing of the information for the device. That's the same mechanism that we had in our previous generation products, like the RM4210, RM4250. It's the same experience that for those of you who have used those products, same experience, and actually the same app. The new version of Bullhorn Tools supports not only the RM5 new generation of RMUs, but it also supports the legacy RMUs like our 4210, 4250, 4211, 4251, and so forth.
Yeah, so the point being, a lot of times you guys buy a satellite unit because you don't have good cell coverage to connect to the internet. And so with the BMCT, with the Bullhorn Tools app, you don't have to have a connection on your phone to, you don't have to have good cell coverage. You don't have to have any cell coverage. You communicate through Bluetooth directly to the SAT unit, set it up, and then it obviously communicates to Bullhorn Web over the satellite radio.
Yep, and there was a comment from William Acevedo. He's in Latin America. We have a great deal of lightning strikes and poor cellular communication. So that's why we are very into reliable satellite comms and surge protection.
Great.
North to south and everywhere in between.
Well, we're confident we can help you out there with this new product.
All right.
Any other questions from the?
I don't think so.
All right.
All right. Thank you, Andrew.
I have one.
Oh, yes.
I have one actually. I was typing it out here and then I just figured, you know what, this is taking too long. In spite of improvements in satellite coverage capabilities over the years, we continue to experience satellite interruptions when there's heavy cloud cover and or associated rain with heavy cloud cover. Sometimes you get major solar flare activity coming off of the sun, and the electromagnetic influence on our environment can cause hiccups and whatever else. In mountainous terrain, it's difficult to get line of sight. We still have some line of sight issues just because of the terrain itself. What I'm wondering is, prior to the installation of a unit, is there some testing? And I'm going to ask my question, and I already kind of have partially answered. I'll partially answer my question. Is there some sort of testing that can be done to ensure the optimum location of the RMU or RM5 antenna? And can it be somewhat remote? And how far remote from the remote monitoring unit can you get? And in the communications industry, this is something that they do. They actually go out to site. They have specialized equipment that they take out there that helps them to determine the optimal location for radio communication systems and the like. Do you guys have something similar, or is there something that's available in industry that would help us in this regard?
No, that's a great question. The mechanism that we provide to help you, position the antenna in really the best possible orientation, best possible location, is in Bullhorn tools. So when you've connected to the device, connected to the system, one of the pieces of information that you can query from the system that actually comes up on kind of the main screen is RSSI. And what this is, it's an indication of the quality or the level of the satellite signal that's it's established with the satellites. And this value can have a range of like 0 to 5, I think is the overall range. And as you get closer to 5, that's kind of the strongest signal. So imagine, the analogy or the course, something you're used to every day would be your cell phone, and you got the bars on your cell phone. This would be analogous to that. You got more bars, you got better connection. And so with a higher RSSI value, you'll have a better connection with your antenna. And so you could, while you're out in the field, if you find that you're getting a lower RSSI value, like a 1 to 2 or 2 to 3, you could reorient your antenna and kind of re-query that value to see if that RSSI value improves. There are things in the environment that are around your RMU, trees. You mentioned mountains. Things that prevent the device from seeing the sky will impact that RSSI. And so, that's something to be conscious of when you're installing, is trying to minimize the amount of obstructions that are in the area. But with this, this Iridium network, the I guess benefit there is that, if you've got obstructions with our legacy devices that are, facing your view towards the equator, you're much limited in the options that you have. Whereas with a low Earth orbit network, if you have obstructions, off to the sides, as long as you're pointing straight up to the sky, then you're more likely to establish that connection. So hope that answers the question.
Andrew, a couple of things too.
Yeah.
So on the cell side, we can work with our cell providers and give them specific lat longs, and they can give us an idea of the coverage in that area. We're new to Iridium here, so that maybe is a good question for us to talk to the Iridium folks about, to find out if they have a similar tool. I suspect they're going to say we have coverage everywhere, but we can check into that for sure. And just to reiterate what Andrew said, the interesting thing about Iridium is you just need a clear view to the sky, and the satellites are passing over at all different angles throughout the day. So it should do better in mountains. And given the frequencies are lower than the geostationary ones, I believe the network will do better in rain and heavy clouds. But I can't give you 100% answer there. You did ask one more question about how far away can that radio module be from the rectifier in this case. And I think it's, how far is it? Do you know, Andrew? It's about 10 meters. Or I think Richard's on the call. Maybe someone on the AI team knows how far can the dome be away from the IO module if you do need to remotely
Yeah, I
install
can't
it?
remember the max spec.
Right. Well, it sounds like we have
We can get
follow-up
back
item
on that one.
Yeah.
but-
Who was? I'm sorry if you. Who was asking that question? We want to make sure we.
Brad
follow.
Wallace, Chuck.
Okay. Great.
So I have a second follow-up question, notwithstanding the benefits of cellular and satellite, because I've been using both for many years. Do you have capabilities if there's fiber optics available?
We don't.
Okay.
No, not right now.
Okay.
But I'd love to
Okay.
learn more about that and what we could do. I mean, that's one of the reasons we wanted to make this modular was, we again just leave everything else the same and maybe modify the communication module.
Yeah.
So when we follow up with you about the distance spec, Andrew, if you could maybe have a conversation about fiber optics, that would be interesting.
Yeah, for sure. Thank you.
Okay,
There was
thanks.
Somebody else, William, I don't know if you still have a question, but we are going over time, that I'll give you a chance here.
Today.
Go for it.
Oh, okay. Good day for everyone. Here's one question about. Okay, let me be quick. Back in 2009, I was working with some first generation of Bullhorn units. They had Orcom satellite network, but there was some minor step back, because when we send a command for interruption or reading, sometimes it took like 30 minutes, like maybe an hour. But I mean, this was mostly about the location. Yes, the location, because we are in the Ecuador, so there's not much coverage of the satellite network back in the days. So here's one question: how much will it take from the time when you send a command from the portal, the web portal, to the actual action in the rectifier? Let's see, for example, a reading, a poll, or some interruption schedule. Do you have maybe some average times for that? I don't know, for that action?
Sure. Yeah. It was actually something that we were discussing with the engineering team just last week. So I guess the answer common to this industry is it depends. So we've seen as little as, a couple of minutes for those signals, for those messages to travel back and forth, upwards of 30 minutes. And a lot of the factors that play into that, one of the biggest factors that Ed mentioned is you've got satellites kind of, migrating at various locations in the field of view of the sky. And so for those scenarios where you might have a satellite right overhead, clear sky, no obstructions, you might see those, a couple of minute turns to get a message back and forth. Whereas let's say you've got a satellite that's moving more on the horizon, and the connection isn't as strong with the device, you might see a half hour for some of those signals to get back and forth. So I think generally the most that we've observed through our testing is about 30 minutes. But again, the best that we've observed is on the order of minutes or less.
Okay, this is not exactly a question. This is just a proposal. Well, I have been working with remote monitoring units since 2008. So yeah, there's a big amount of challenges here in Latin America, very huge challenges. So I hope maybe there's a chance to share these experiences with you and your team. I will be more than honored to share that humble knowledge. I have some video footage, some particular conditions. Yes, so I will be more than happy to share this experience with you. So you just tell me, how can we move forward with this?
Sure. Yeah, we'll reach out to you after, we'll make contact with you, and yeah, I'd love to get your feedback on the products. That's what helps us to constantly improve, and then introduce new products that solve the challenges that you're facing.
Yeah, there are some little, I don't know, wish list that some customers have here. Very unusual. Yes, sometimes they use automatic rectifiers or DC PWM control rectifiers. So maybe they wanted some analog signal output from some devices to just control that thing. But that's I don't know. That's other lens, but maybe there are some suggestions, no, for that, for new possible development of products. So that's what I finished. Thank you very
Okay.
much.
Yeah.
Sure.
Thank you.
Yeah.
Thank you, William.
you.
I appreciate people hanging on a few minutes after 9:30. Thanks for joining us. Look forward to talking to everybody in July. And thank you, Andrew, for your presentation. Have a
Sure.
great day, everyone. Bye.
Thanks.